Hi, welcome to a live edition of Physics Center. I'm Festus Schoaf, and this is my partner, Poindexter Baum.
Hello everyone. Today we have an interview with Dr. Curtis Tubb on the physics of sports, live highlights from around the world, and a special fact or fiction segment. Now let's send it over to Star Glitz for the interview with Dr. Curtis Tubb. Star?
Thanks, Poindexter. Welcome to our special interview with our guest, Dr. Curtis Tubb. Hi, Dr. Curtis Tubb. Glad to have you here.
Glad to be here, Star.
Alright, let's get down to the nitty-gritty and talk about the physics of sports. What exactly are projectiles?
Well, in my paper published by MIT, I stated, and I quote, "A projectile is an object upon which the only force acting is gravity." There are a variety of examples of projectiles. An object dropped from rest is a projectile, an object that is thrown vertically upward is also a projectile, and an object which is thrown upward at an angle to the horizontal is a projectile, provided that the influence of air resistance is negligible. A projectile is any object that once projected or dropped continues in motion by its own inertia, and it's influenced only by the downward force of gravity. By definition, a projectile has a single force that acts upon it, the force of gravity. If there were any other force acting upon an object, then that object would not be a projectile. Thus, the three-body diagram of a projectile would be shown a single force acting downwards and labeled force of gravity, regardless of whether the projectile is moving downwards, upwards and rightwards, or downwards and leftwards. The three-body diagram of the projectile is still as depicted in which the diagram at the right. By definition, a projectile is any object upon which the only force is gravity.
Wow, now what exactly does that mean?
Basically, stuff flying through the air. Projectiles are seen everywhere in sports, so you guys might be more familiar with them than you think, like a golf ball shot, a basketball shot, or a gun shooting a bullet.
Well, let's see if he knows just as much as we think he does with an example problem. A projectile is launched horizontally from the top of a tower of height y and velocity v. After t seconds, the projectile lands at a distance x from the base of the tower. If the projectile is launched from the same tower at a velocity of 2v, the time of the projectile remains in the air is closest to what?
I believe the time would stay at the same, t seconds.
That is correct. If the projectile is launched from the same tower at a velocity of 2v, then the distance of the projectile lands from the base of the tower closest to what?
Think you're trying to stump me, huh? I believe the distance would be 2 times longer.
That is also correct. Thanks, Curtis. It's been a pleasure having you here.
It's my pleasure.
Thanks for the fantastic interview, Star. I'm Dallas, and I'm here with Marcus, a former physics world champion in projectiles. And we're going to play a little game called Fact or Fiction, where I read a statement, and then Marcus answers whether it's fact or fiction. First, statement. While in flight, a projectile's horizontal velocity remains constant.
I'm going to have to go with fact.
Wow, great job. Second, the acceleration due to gravity changes based on the weight of the object.
That's fiction. It doesn't change at all.
Right. 3. The vertical velocity of an object is constantly changing.
Fact again.
Nice. 4. Air resistance does not change the projectile's path.
That one is fiction. It does. That's why we say it's negligible in our problems.
Right. The angle of takeoff equals the angle of impact.
Fact.
Alright. 6. The vertical distance traveled by a projectile is called its range.
That's fiction. The horizontal distance is range, not vertical.
There we go. And lastly, the x initial, v initial, and time are all variables of the projectile.
That one's fact also.
Good job, Marcus. After a great game of Fact or Fiction, we're on to the next segment of Cold Hard Facts, where I ask Marcus a question and he's going to answer. Alright, for background info, a projectile is launched from ground level at an angle of theta with a velocity of v. The first question is, what angle theta will cause the projectile to remain in the air the longest?
90 degrees, because the object will be going straight up, then straight down, and this movement takes the longest amount of time.
Right. Alright, next question. What angle theta will cause the projectile to have the greatest range?
45 degrees, because the object won't be too high or too low, causing the object to travel a further horizontal distance.
That makes sense. Last question. What angle theta will cause the projectile to reach the greatest height?
90 degrees, because the object will go straight up, making it the highest object.
Perfect. We're back from Cold Hard Facts, and we are here to show you the UNC Duke doubleheader for yesterday's games.
And after the highlights, we have a shot analysis for the folks back home by Dr. Curtis Tubb.
Enjoy. Get the offensive rebound. Lucky roll. The spin move, and somehow he gets it in. Coming in strong, barely misses. Gets the offensive rebound, comes in hard. Oh, that dunk! The three, okay.
All right, tonight we have an ESPN special. Duke vs. North Carolina. And starting for Duke at 6'4", power forward, number 12, Cole Mueller. And on the other side, starting at point guard, number 2, the 4'2", mighty man, Michael Neenan. Brilliant season so far. He'll drive left. Nothing there, he does scoop. Oh, it's a beautiful move. This is going to be an interesting matchup, folks. North Carolina has not lost a game all season. Duke has only lost once. Neenan, the J. Oh, he banks it in. 3-1.
It's not open at night.
Interesting fact about Cole Mueller here, he has a 1.7 GPA. He is not eligible to play. He has snuck onto the court here tonight. And he's driving right, back left, he's backing him down. Oh, what's he gonna do? Oh, the reverse jam with authority. Ice cold. It's been about a few minutes since he's made a field goal here. Cole, back down to the paint. The up and under move. He says, I don't care about your grades, Mr. Neenan. Oh, Michael strips the ball. Cole recovers. Cole driving right, going back to the lane. Oh, the fake. He drives back, the reverse jam. You will be seeing that later tonight on SportsCenter's Top 10 Plays. Basket, desperately, drives right, step back. Oh, he's caught up and under. Oh, he works magic. Face, look at the emotion. He wants this victory. Cole playing with more authority. He's got a lane and a dunk for the win. Michael visually upset.
We're back after 2 phenomenal Duke UNC games. Duke takes both games, but UNC still in it. Now we're here to show you the Curtis Tubb interview for some analysis.
Hello, Doctor. Welcome back to the set.
Thanks for having me back.
What did you see out there in relation to projectiles today during the games?
So what I'm going to do is I'm going to have a shot analysis of 2 different shots that were taken in the game. One by UNC's point guard Michael Neenan, and one by Duke's shooting guard Zach Strasser. So in the first shot I'm going to talk about is Michael Neenan's. What he did is, if you put your hands here like as if you're shooting and you drew a horizontal axis from his wrist straight out, his hands were too far back, higher I would say than 45 degrees. This gives the ball a more of a vertical lift and not enough horizontal distance. This is why his shot was an air ball, but he did not get blocked, which is one thing that helped him. But in Zach's shot, he was at about a 45-degree angle if you also drew the horizontal axis. This gave him enough vertical lift to not get blocked, but also enough horizontal take so that he could get the ball to the basket.
Interesting. So can you just go really quickly into more detail on what Michael could have done to better improve his shot?
Just once again, I would follow with what Zach did and do more of a 45-degree angle so that he can get the ball to the basket and have enough vertical lift to not get blocked.
It's been a pleasure, Doctor.
Thank you for having me.
Ow now, brown cow. Ow now, brown cow.
Ribs. I had ribs for Unique New York. Unique New York.
Hey, how's your wife been, Steve? Is she good? Oh. Oh, I love water.
5 seconds, 5 seconds.
I don't believe you, sir.
Now, 3, 2,
We're on
1.
My name is Festus Show.
And I'm Poindexter Baum.
Thanks for tuning in today, and we look forward to seeing you on another live edition of Physics Center later on this week.